I'm Lee Pruitt from Microsoft. I'm actually going to be wearing a couple of virtual hats here at the kind of close of the session. Uma Parapelle, who was supposed to be chairing, had a family emergency and was not able to make it, so I'm kind of standing in for him. And then I'll also be standing in for Scott Lee from Microsoft on the Windows drivers section because he was not able to travel either. So with that, trying to start off the process, we're going to have Arvind here from VMware. So he's a senior product line manager in the vSphere platform. Arvind Jagannath works in product management at VMware with over 25 years of experience in the industry working on networking, storage, embedded, and kernel development. He currently leads infrastructure and core platform enablement for vSphere, working across the VMware ecosystem of server, I/O, and storage partners. Arvind most recently drove platform product management at Cohesity and NetApp. Arvind holds an MBA from the University of Chicago Booth School of Business and a bachelor's in computer science and engineering. So he's going to talk about what's happening with VMware and NVMe. So thank you.
So I'll be mainly covering the vSphere NVMe driver and stack support. Basically, what we have been working on over the last around 2 to 3 years. Of course, we have been partnering with some of the known storage array vendors in the industry, and it was good. Good that Eric and Curtis went before me because essentially what we are targeting is or what we have been working on is some of the very things that they talked about. So along with me was Murli, who actually was one of the key players who has been working on the VMware side with our partners. So he's out sick, and I'll be covering some of his part too. So this is our standard disclaimer. Essentially what this means is that some of the things are work in progress. We don't make any firm commitment on any of these things. We don't make any claims. So essentially, I'll be talking about this from a VMware perspective. So, when we work on some of these newer protocols, what is VMware looking for? So, I mean, VMware has a long history in the industry, and we have supported all kinds of storage array partners, different protocols. We have been very strong in fiber channel, for example. We have been also working closely with some of the NVMe vendors. So NVMe is central to some of our plans. So we have been working on NVMe and NVMe or Fabric for about, I think around 10 or 10 plus years. So what are some of the motivations? I mean, basically we are a virtualization platform, but we are constantly looking to bring latency and performance close to bare metal. Of course, we want all the applications that run on our platform to perform close to bare metal, which means that we are constantly working on our stack, trying to improve on different aspects of performance, right from the VM to all the way to the drivers on the host. So examples of that, we improved scale, for example, namespaces and number of paths. We are also working on a lot of fabric manageability and standards, some of them that Eric and Curtis talked about. We are also focused on consumability and resiliency. So since we are very customer centric in the sense that we want the workloads to be running pretty agnostic of a lot of the underlying complexities. We want to make the consumability very, very transparent, very efficient for our customers. Um, for example, recently we have been working on things like vwalls for NVMe or Fabric, support for migrations, DRS, etc., clustered usage. Security is another focus across the board, not just on the NVMe front. But for NVMe or Fabric specifically, we are looking into some of the newer standards that cover authentication and encryption. We are also, I talked about continuously improving the stack. We are trying to find, any sort of optimization that we can make. And I'll talk about a few of them in the next few slides. So one of the things I also wanted to highlight today is the hardware offload. So we are looking into, working with some of the DPU or IPO vendors to see how we can potentially improve on storage performance on the source, on the initiator side. So some of the high level updates. So NVMe TCP is currently, is getting a lot of effort on VMware side. Standards. So we are working on a lot of the TPs on Fabric management. We also supported the abort so that we can have the scale, and also we can have more resiliency, performance and scalability optimization. So this is independent of the standardization within the stack. This year, we have been able to achieve as much as 8 million IOPS on reads. So basically, this is with a new mechanism called hybrid polling. This has dramatically improved from what we earlier claimed in some forums, which was up to around 3.5 million. So now we have been able to see up to 8 million IOPS, basically with a virtual environment. In terms of the storage stack itself, we are supporting both direct attached and NVMe or Fabric. I mentioned namespaces, paths, NVMe reservations. So VMware is a huge believer in doing host-based sharing of storage resources. So we are supporting NVMe reservations. And that is coming in an upcoming vSphere release. So pass-through, on pass-through, a lot of the partners that we work with, they actually look to support pass-through with NVMe. So although this is not completely compatible with this session, I just wanted to highlight that pass-through is important, and for a lot of our partners, they create solution with pass-through, and they look into providing the scale and things such as hot plug capabilities, and also they look to provide resiliency with DPC, basically passing the PCI error and doing error recovery. LED controls is another thing that keeps coming up, and we work on. vWalls is a new thing which we are planning on supporting with NVMe or Fabric. So FC is going to come soon, and then we are also going to support RDMA and TCP. So VMware partner ecosystem is huge. So we support around, last when I checked, around 1900 listings of HP and firmware, right, across dozens of vendors. So we support IO vendors, array vendors, OEMs, OEM branded components. So things like, on the HBA side, RAID devices, tri-mode controllers, RDMA and FC controllers. And on the OEM side of things, we work with them both on direct attached NVMe and NVMe or Fabric, and collaborate closely with them. So the release features, in 7.0U3, we came up with the NVMe or TCP for the first time. We started supporting it. We also certified 2 array vendors, and there are more in the pipeline. And we supported some of the TPs, which makes manageability easier. So NVMe or Fabric Discovery, we supported a non-persistent version of that. And then, as you can see on the right hand side, we completed that, and we are going to support persistent connections. So that will make it more efficient and faster. On the left hand side, we also did TP for 4097 abort enhancements, and the central discovery controller support with 8010. And some of the things that are coming in 8.0, we will be supporting MDNS with TP 8009, and NVMe reservation support for Windows Server failover cluster like use cases. vWalls with NVMe, but we'll be releasing it for FC first, and then subsequent releases will be looking into TCP and RDMA. And we did scale the namespaces from previous 32 to 256, and support 2K paths. So this is just a quick highlight on one of the runs that our performance team did. So this is basically just showing iSCSI compared to NVMe TCP. Overall, we do see that NVMe TCP has the potential to offer more performance improvement. Again, disclaimer is this is a very specific test under controlled conditions. So this may not be replicatable across the board, but this is just one of the results that I wanted to show. So basically, we see up to 2.4x improvement for random write, and 3.7x improvements for random reads. So future roadmap, we are so one of the things we are supporting is end-to-end NVMe in the storage stack. So basically what that means is we had some translations in our storage stack which made it a bit inefficient, in the sense that we used some of the legacy SCSI paths in our and that we are trying to make it such that right from the VM to all the way into the driver and out into the network, we use an end-to-end NVMe without requiring any sort of translation. So the same NVMe command can potentially traverse across the stack and all the way could be going to the storage array. So that's the goal. On the security side, we are looking to provide in-band authentication and support for TLS 1.3 and AVE with TP 8019, and boot over NVMe TCP. Some of the work on dispersed namespaces, for example, for metro cluster like use cases. And TP 8013 after that's an extension for some of the authentication work. We'll also be working on I think TP 8009 might already be coming, so this may be a mistake. So but we'll be working on 4033, the advanced command retry enable and max data transfer for non-IO commands, TP 4040. And vVols, like I mentioned previously, will be supporting vVols for all the three fabrics. And we are right now actually working with some SmartNIC vendors on looking to do NVMe or fabric offload, and basically integrate it with I mean, it's basically the next phase of our SmartNIC initiative, where we also did some of the networking offload. So that's my update.
So my first virtual hat here is to be Uma Harpali. Uma is currently working in a stealth startup, so we can't talk too much about what he's doing now, but Uma has been a long time storage industry veteran who has been very instrumental in kind of developing and pushing the open source UEFI NVMe implementation in the core UEFI code. So with that, we just want to talk a little bit about, what UEFI is, an introduction around what's happening there, and then talk about the current status. So I think probably most people know UEFI is the new extensible firmware interface that kind of replaces the old BIOS and allows us to basically have many of the different boot services that allow the operating system to load. And of course, a very key part of that down there at the bottom is that if you want to boot from an NVMe device, you need support in your BIOS or UEFI to make that happen. So, yes, the Unified Extensible Firmware Interface, 64-bit platform firmware. Part of the new idea here is making sure that we have a common standards-based, vendor-neutral driver, NVMe driver, to make sure the pre-OS boot works and brings up the OS. And so the idea here is it gets rid of that need for legacy option ROM to support NVMe boot, which is a cost, of course, on any of the boot devices. And trying to basically using this new UEFI with all of the debug hooks that UEFI now has to be able to look at early boot issues and boot handoff issues between UEFI and the OS. Very important. And so, kind of current status, industry tested and reliable. It's all built up on the NVMe specifications, runs across multiple vendors' drives, and is tested across the ARM OCP platforms. That's kind of one of the newer things. Plug-in and boot functionality independent, as we say, of NVMe vendors. And standards for all the different server types, Intel, ARM, AMD, as well as client devices. How do we say what Curtis says? Is like, well, I don't know if anything's ever bug free, but hey, it's been heavily tested. It's been shown to be very robust. Allows for seamless handover of the boot functionality. All kinds of different operating systems from Linux, Windows, FreeBSD, and others. There's been some fixes around some of the handling of the NVMe commands to make things more robust, getting rid of some of the legacy stuff that was in there. I think Arvind talks about that in some of the VM stack. There's a lot of SCSI underneath a lot of things, and we're trying to get rid of a lot of that. And I'll talk about that in Windows as well later. And then there's obviously still new features being added as the UEFI specification evolves and make sure that, everything stays in lockstep and that we can all boot our machines happily. So now I'm not sure. I can ask for questions. I might not be able to answer them, but if either we can capture them and maybe Uma can do that offline later if there's anything somebody wants to talk about. Great, sounds good. So with that. Now, taking off my UMA hat, put on my Scott Lee hat. Scott Lee is a principal development manager at Microsoft. He's in the Windows group basically and owns the StorePort and the StorePort mini ports, which include Store NVMe, the driver that runs NVMe devices in Windows. So kind of what we want to talk about today, some of the driver feature support, device handling and detection and error recovery, and features, right? So kind of the canonical place to go and find information about what features does a given Windows release support for NVMe. Here are the Microsoft documents. Make sure that you go out there to take a look at that. Obviously, there's a lot of what's happening right now in Windows is because StorePort is a SCSI base. There is a translation layer there that happens between SCSI and NVMe, and we talk about that translation support and how that works across the various OSs. Some of the recent changes, lots of improvements to handling hot add and remove of not only devices, but namespaces on a given device. So kind of what I want to kind of delve into more deeply here is basically what we call error recovery. This is a new feature that's been added to the OCP specification. Probably many of you are familiar with all of the devices in Azure are required to follow this specification. And what we're trying to do here is basically built-in mechanisms that, well, hey, we always hope that the SSD runs along fine, is robust, doesn't have any problems. But as we well know, at the end of the day, there are issues in firmware. There are issues with sometimes in the operation of the drive, some sort of upset event or something like that. And sometimes the drive needs a little help getting itself back together. So the detection here is based on either an asynchronous event notification that's preferred, or you can also set controller fatal status in the drive and we'll detect that and do the right thing. Feature discovery is based on the C1 log page that we've defined in OCP, and the workflow can also be used to handle other device conditions other than, say, a panic or a hang, hardware errors and things like that. So how do we discover this? Basically, the flow happens that during driver initialization, we're going to go out and read that log page. We're going to kind of make sure the conditions are met here about what's happening. There's all the OCP pages have GUIDs on them so that we know that they're what we think they are, hardened against reading bad data. And we kind of save some kind of pertinent information from the page there. It's like the capability, there's a structure that will show that talks about, hey, how long, if we detect these panic condition or hang, how long should I wait before I do an action on the drive? And so with that then is a series of actions that the drive advertises saying kind of from minimal invasive to most invasive saying, I need you to do a PCI reset or I need you to do a power cycle or that sort of thing. So we wait that time and then we'll go ahead and do that action and then wait and do the recovery action based on that. And we'll talk a little bit more in depth about that. So once we've kind of gathered all that, we arm the asynchronous event, and at some point, maybe the drive, unfortunately, has to send us one. So part of that notification, as I said before, we support both CFS or the completion of an asynchronous event request. What that really does is the event request is basically going to point us back to the page again, of course, and tell us basically what we're going to have to do next. So what we kind of do here is, so we save the information, we take in the hang and provide a panic ID field and the device recovery action. So part of that, we expect the device to send us a controller initiated telemetry log request as well, which we will then gather before doing much of anything else. So as I said before, host detects device hang, waits for the panic reset wait time. If there's any internal kind of post-processing, post-mortem that the drive needs to do before that we kind of go ahead and get the recovery action taken to clean this up. So there's kind of, as I say again, these different recovery actions that we start on, controller reset being kind of the minimal invasive one, then up through PCIe functional, conventional hot, subsystem, and burst. And it's really, this is kind of one of those things that we're hoping we can do the middle one, and the drive can set more than one of these. If it only wants, if it knows it can do everything it needs to do in just one, then just set one bit. If you think there are other, you have different classes of hangs and different things that need to happen to get the drive back, then set more than one bit. And what we'll do is we'll iterate through each of those in turn. And basically the idea is that, hey, if one of them is successful, then the controller initialization is going to succeed and we'll get back to at least the admin queue state. So after that process and we get a successful initialization of the controller, we're going to go and read that C1 log page again, kind of note the panic ID field. As non-zero says, yes, we're still in a panic. And then what we're going to do is look at the device recovery actions. So the host should retrieve trying to get the controller initiated log because the drive knows something went wrong. And so it really should be telling us what that's about so that we can debug that with the vendor. And in the ability to service I/O, kind of depends on what the condition is encountered. Basically, we say is if you can't guarantee the data integrity, then don't do I/O, and we'll go from there. And then with that, you've kind of you've advertised as what the recovery needs to be. We will then perform that. In some cases, maybe it's, hey, I just needed a quick bang up the side of the head with a reset, and that's all we needed to do. But oftentimes, it's usually what we see is format NVM is really what needed, because what's happened is metadata has been corrupted or DRAM corruption or something like that, that the data really can't be, integrity of the data can't be guaranteed. And so what we want to do is, okay, yeah, that's not good, but as long as we can go and format the drive and get the drive back and start using it again, that's a win, because otherwise we have to do an RMA, and nobody wants that. So, features. As I say, a lot of what's to date, a lot of the different places we end up with SCSI stack, and so you end up with a mini port driver for NVMe that does a translation in and out, and with that. Especially as we may move into a future where hard drives use an NVMe interface, if anybody's ever heard of what we're doing there, then the need for SCSI pretty much disappears. And especially now as the SSDs are getting, the latency on the SSDs is getting so low, what we want to do is get rid of that translation layer and kind of homogenize the stack around NVMe instead. One of the things we're looking at, NVMe over Fabrics, initiator support, and of course, a lot of the stuff that's been in NVMe 2.0.